So, this lesson is about number types: whole numbers, integers, decimals, and fractions. These are the words questions use when they want you to describe what kind of number you are dealing with. It is not about making maths sound fancy. It is just about being able to look at a number and say, okay, I know what this is and I know where it belongs. The number line is the main idea. Every number has a position somewhere on the line. Numbers further to the right are bigger. Numbers further to the left are smaller. That rule works for positive numbers, negative numbers, decimals, and fractions. So, if you are comparing two numbers, the question is basically, which one sits further to the right? 0 is important. It is not just an empty space in the middle. 0 is a number. To the right of 0, we have positive numbers. To the left of 0, we have negative numbers. So 3 is to the right of 0, and negative 3 is to the left of 0. This is where negative numbers can catch people out. Negative 3 is smaller than negative 1, because negative 3 is further left. I know the digit 3 looks bigger than the digit 1, but the negative sign changes the position. If you think about temperature, negative 3 degrees is colder than negative 1 degree, so negative 3 is smaller. Now think about the gap from 3 to 4. That is one whole interval. A number like 3.456 sits inside that gap. It is bigger than 3, but it has not reached 4, so already we can say it is between 3 and 4. Later, we will make that position more accurate using decimal place value. Now let's talk about whole numbers. Whole numbers are 0 and the positive counting numbers. So that means 0, 1, 2, 3, 4, 5, 6, and it keeps going. Whole numbers land exactly on the main tick marks. They do not have decimal parts. They do not have fraction parts. They are not negative. 0 is included. That is worth saying properly because it is a common mistake. 0 is a whole number. 1 is a whole number. 2 is a whole number. 10 is a whole number. 246 is a whole number. 912 is a whole number. But negative 1 is not a whole number because whole numbers do not include negatives. 2.5 is not a whole number because it sits between 2 and 3. 1/2 is not a whole number either because it is part of a whole, not a whole number step. A quick check is this: is the number 0 or is it a positive counting number with no decimal part and no fraction part? If yes, it is a whole number. If not, it is not a whole number. Now integers are similar, but they go further. Integers are whole number steps in both directions. So positives are included, 0 is included, and negatives are included as long as the number is an exact whole number step. That means -4, -3, -2, -1, 0, 1, 2, 3, and 4 are all integers. They all sit exactly on whole number tick marks. There are no decimal bits and no fraction bits. So the difference is this: whole numbers start at 0 and go to the right. Integers go to the left and to the right, and they still include 0. 3 is both a whole number and an integer. 0 is both a whole number and an integer. -3 is an integer, but it is not a whole number. Integers are useful because they let us talk properly about numbers on both sides of 0. A positive integer sits to the right of 0. A negative integer sits to the left of 0. The number 0 sits between them. The important thing is that integers do not have decimal parts or fraction parts. So -2 is an integer, 4 is an integer, 0 is an integer. But 2.5 is not an integer because it lands between 2 and 3. 3/4 is not an integer because it is a fractional amount. -2/3 is not an integer either because it does not land on a whole number tick mark. If you are ever unsure, ask yourself, could I get to this number by counting in exact steps of 1 from 0? If yes, it is probably an integer. If it lands halfway between steps or somewhere between steps, it is not an integer. Now let's move to decimals. A decimal is a number written with a decimal point. The digits after the decimal point show smaller place values. For example, 3.456 is a decimal. For speech, say it as 3.456. Do not say 3.456. After the decimal point, we normally read the digits one at a time because each digit has its own place value. In 3.456, the 3 is the whole number part. The 4 is in the tenths column. The 5 is in the hundredths column. The 6 is in the thousandths column. So the number means 3 ones, 4 tenths, 5 hundredths, and 6 thousandths. Decimals can sit between whole number ticks. 3.1 sits between 3 and 4. 3.4 sits between 3 and 4. 3.9 sits between 3 and 4. 3.456 is also between 3 and 4, but it is more precise. The decimal point separates the whole number part from the smaller parts. The more digits you have after the decimal point, the more accurately you can describe the position. Tenths are smaller than ones. Hundredths are smaller than tenths. Thousandths are smaller than hundredths. Now fractions. A fraction shows equal parts of a whole or equal parts of an interval. Take 3/5. The top number is called the numerator. The bottom number is called the denominator. The denominator tells you how many equal parts the whole has been split into. In 3/5, the denominator is 5, so the interval from 0 to 1 is split into 5 equal parts. The numerator tells you how many of those parts you count. In 3/5, the numerator is 3, so you count 3 equal jumps from 0. That word equal matters. If the parts are not equal, the fraction has not been placed correctly. Fractions only make sense on a number line when the spacing is even. So 3/5 means 1/5, 2/5, 3/5. The point is not random. It has an exact position. This is why fractions are more than just pizza slices. For maths, it is better to think of them as exact positions on a number line. A simple way to remember it is denominator for divisions, numerator for jumps. The denominator decides how many equal pieces make the whole. The numerator decides how many pieces you count. Now, let's place a few fractions in a more practical way. 1/2 means the interval from 0 to 1 is split into 2 equal parts, and we count 1 jump. So 1/2 is exactly in the middle of 0 and 1. 3/4 means the interval from 0 to 1 is split into 4 equal parts, and we count 3 jumps. 1/4, 2/4, 3/4. That puts 3/4 closer to 1 than to 0. Fractions can also be negative. -2/3 sits to the left of 0. The denominator is 3, so we are thinking in thirds. The numerator is 2, so we count 2 jumps. But because the fraction is negative, those jumps go to the left. -2/3 is less than 0, but greater than -1. Fractions can also be bigger than 1. 7/4 is an improper fraction because the numerator is bigger than the denominator. 4/4 make 1 whole, so 7/4 is 1 whole and 3 more quarters. That means 7/4 sits between 1 and 2. So the method is the same each time. Find the interval, Split it into equal parts using the denominator. Count the jumps using the numerator. Then check whether the fraction is positive, negative, or bigger than 1. Now let's classify numbers. This is where GCSE questions can be a bit sneaky, because one number can fit more than one category. 0 is a whole number and an integer. It is a whole number because whole numbers include 0. It is an integer because it is an exact whole number step. 3 is also a whole number and an integer. It is a positive counting number and it lands exactly on a whole number tick mark. -2 is an integer, but it is not a whole number. It is an exact whole number step, but it is on the negative side, and whole numbers do not include negatives. 3/4 is a fraction. It shows equal parts. It does not land on a whole number tick mark, so it is not an integer and it is not a whole number. 2.5 is a decimal. It sits between 2 and 3, so it is not a whole number and not an integer. 3.456 is also a decimal, because it uses digits after the decimal point to give a more precise position. So the checklist is simple. 0 or a positive counting number with no decimal or fraction part means whole number. A whole number step, including negatives, means integer. A number with a decimal point means decimal. A number written as equal parts with a numerator and denominator means fraction. Now let's locate 3.456 more carefully. Start with the whole number part. The number begins with 3, so it is between 3 and 4. That is true, but it is not very precise. The 10th digit is 4, so the number is between 3.4 and 3.5. That is a smaller interval. The 100th digit is 5, so the number is between 3.45 and 3.46. That is even more precise. The 1000th digit is 6, so the number is located at 3.456 to 3 decimal places. Each decimal place makes the interval 10 times smaller. 1 split into tenths, tenths split into hundredths, hundredths split into thousandths. That is what decimal place value is doing. Now, let's use number lines to order numbers. Ordering means putting numbers in size order. Ascending order means smallest to largest. On a number line, that means read from left to right. Start with whole numbers, 13, 5, 21, and 8. The smallest value is 5, then comes 8, then 13, then 21. So the ascending order is 5, 8, 13, 21. This one is straightforward, but the method matters. Do not just guess. Think about where the numbers sit. The one furthest left is smallest, and the one furthest right is largest. Now, decimals to 2 decimal places, 2.37, 2.05, 2.40, and 2.31. They all have the same whole number part, which is 2, so we compare the decimal places. 2.05 has 0 tenths, so it comes first. 2.31 and 2.37 both have 3 tenths, so we compare the hundredths. 100th is smaller than 700ths, so 2.31 comes before 2.37. 2.40 has 4 tenths, so it comes after both of those. So the ascending order is 2.05, 2.31, 2.37, 2.40. Be careful with 2.40. The 0 at the end does not make it smaller. 2.40 is the same value as 2.4, and it means 2 and 40 hundredths. 40 hundredths is bigger than 37 hundredths, so 2.40 is bigger than 2.37. Now, integers, 4, -3, 0, and -1. Ascending order means smallest to largest. -3 is furthest left, so it comes first, then -1, then 0, then 4. So the order is -3, -1, 0, 4. This is the classic negative number mistake. -3 is not bigger than -1. -3 is further left, so it is smaller. Now for the larger integer example, 246, -152, -50, and 912. These numbers are spread out, so mentally we need a wider scale. Start with the negative numbers. -152 is further left than -50, so -152 is smaller. Then comes -50. After that, we move past 0 into the positive numbers. 246 comes next, and 912 is the largest. So the ascending order is -152, -50, 246, 912. The method has not changed. Whether the numbers are whole numbers, decimals, or integers, we place them by size and read from left to right. So here is the recap. Whole numbers are 0 and positive counting numbers. Integers are whole number steps, including negatives. Decimals use a decimal point to show smaller place values. Fractions show equal parts of a whole or interval. For fractions, denominator means divisions, numerator means jumps. For decimals, compare place value carefully. For integers, remember that negatives further left are smaller. And for ordering, ascending order means smallest to largest, which is left to right on a number line. Every number has a place. Once you know where it sits, you can classify it, compare it, and order it.